Welcome to the course Design of Structures I. This course will introduce you to the principles and practices of designing safe, efficient, and modern structural systems. The aim is to equip you with the ability to not only analyze but also design structural elements, considering materials, building regulations, and practical applications. This first module focuses on fundamentals of design, building codes, structural philosophy, and the design of reinforced concrete structures. We will also touch on the integration of computer-aided design in modern practice. Section 1: Fundamentals of Structural Design. Structural design is the art and science of planning, sizing, and detailing elements of a structure so that they can safely withstand applied loads throughout their intended life. The fundamentals of design involve understanding loads, including dead loads, self-weight, live loads, people, furniture, vehicles, wind loads, earthquake loads, and environmental effects. Determining structural behavior, how materials respond under tension, compression, bending, or shear. Safety and serviceability, ensuring not only strength but also comfort and usability of the structure, for example limiting excessive deflection or vibrations. Durability, designing for long-term resistance to corrosion, fire, fatigue, and weathering. Section 2: The design process. The design process in structural engineering typically follows these stages. Conceptual design, defining the overall structure, load paths, and system type. Preliminary design, estimating sizes of key members to check feasibility. Detailed design, performing full calculations and choosing reinforcement, connections, and dimensions. Documentation, preparing drawings, schedules, and specifications for construction. Review and approval, ensuring the design complies with regulations and is verified by peers or authorities. This process is iterative, meaning engineers often revisit earlier steps as new information becomes available. Section 3: Material selection in structural design. Material choice plays a key role in determining strength, durability, cost, and appearance of structures. Common structural materials include reinforced concrete, versatile, durable, and economical. It performs well in compression and, with reinforcement, also in tension. Steel, strong, ductile, and suitable for long spans or tall structures. Timber, sustainable and lightweight, often used in housing or architectural projects. Composite systems, combining steel and concrete to take advantage of both materials. Engineers must balance performance, cost, and sustainability when selecting materials. Section 4: Building regulations and codes of practice. All structural design must comply with building regulations and codes of practice, which are legally binding documents ensuring safety and uniform standards. Codes specify minimum load requirements, material strengths and safety factors, detailing rules, such as minimum reinforcement spacing or welding standards, serviceability requirements like allowable deflection. Examples of widely used codes include Euro codes, American codes such as ACI and AISC, and national codes like the Nigerian Building Code. Section 5: Design philosophy, elastic, load factor, and limit state methods. Structural engineers use different philosophies to ensure safety. Elastic method assumes structures behave linearly, with stresses proportional to loads. This method is simple but conservative. Load factor method applies different safety factors to various loads, recognizing that not all loads act simultaneously. Limit state method, the modern standard. It considers two categories: the ultimate limit state, which ensures strength and safety, and the serviceability limit state, which ensures comfort and usability. The limit state approach balances safety, economy, and realism in design. Section 6: Design of reinforced concrete elements. Reinforced concrete is central to structural engineering. The combination of concrete and steel reinforcement allows us to design beams, slabs, columns, and foundations that can carry substantial loads. Key reinforced concrete elements include Beams, designed to resist bending and shear. Slabs, horizontal plates that distribute loads to beams and columns. Columns, vertical members carrying mainly compressive loads. Foundations, transferring loads from the structure to the soil. Design involves choosing dimensions, reinforcement arrangement, and detailing connections to ensure safety and durability. Section 7. Computer-aided design in structural engineering. Modern structural engineering increasingly relies on computer-aided design (CAD) and structural analysis software. Tools like AutoCAD, Revit, STAD Pro, or SAP 2000 help in creating precise drawings, running simulations of load effects, optimizing material use, detecting errors early in design. CAD not only speeds up calculations but also enhances accuracy, enabling engineers to tackle complex geometries and larger projects. In Module 1, we introduced the fundamentals of structural design, the structured design process, material selection and its impact, building codes and regulations, different design philosophies, with emphasis on the limit state method, reinforce concrete design basics, the role of computer-aided design. With these foundations in place, we will now proceed to Module 2, which expands to steel structures, connections, foundations, composite systems, and modern structural forms.